In this clip, we're going to talk about organization structure, avoiding disaster, and how is type 1 and type 2 error tied into the whole business. So we're going to start with the cliche example of Challenger shadow explosion. Before the Challenger launched, engineer actually warned the management that the O-ring might malfunction, and that will lead to a fuel leak, which will ended up being a terrible disaster, which is exactly what happened. So the question now we ask is, how will different organization structure shape the answer of the management to this very question? So the first organization structure we're going to consider is a serial structure. So before we actually go into answering this question, we are going to introduce the idea of type 1 and type 2 error in this case. So in this case, so the type 1 error in statistical work means we reject the null hypothesis when the null hypothesis is true, and type 2 error is we fail to reject the null hypothesis when it is actually indeed false. So in this case, the null hypothesis that we want to reject is that shadow is actually not safe to launch. So we should not launch a shadow. So the type 1 error will be we launch a shadow despite that it's actually not safe to launch. And the type 2 error will be we did not launch a shadow when actually it is safe to do. So now let's assume that the probability of committing type 1 error is A, and the probability of committing type 2 error is B. Okay, so now we're going to introduce two organization structure. So one structure is serial structure, and another structure is parallel structure. So the serial structure means that both units has to approve the command before actually it will go the decision will go through, and a parallel structure means only one unit needs to approve the plan. So now let's consider the actual probability of type 1 and type 2 error in both cases. If we assume that each unit has probability A to commit type 1 error and probability B to commit type 2 error. So for the serial structure to commit a probability a type 1 error, it has to be both units are rejected now when it's true, which means both units think it's safe to launch when actually it's not. So let's write down the probability. So in this case, that means both units, let's say we have two control units, has to approve the shuttle launch when it's actually not safe to launch. So let's write down the probability of this event. So in this case, that means unit A has to approve and unit B has to approve. And we assume that they are independent units. So that is just the product of the two independent type 1 error. Now let's consider what is the event for type 2 error. Type 2 error means that at least one of the units says no to the launch when it's actually safe to launch. Or we can frame it. So in that case, if both of them reject, either one of them reject will suffice to make a type 2 error. So we can make our life easier if we just assume we will take 1 minus the probability that both agents approve the launch when actually it is safe. So we write the event, and we will notice that this is 1 minus the probability of both agents approve the launch when it's safe, we don't actually know this quantity, so we need to translate that into a quantity that we know, which is type 2 error, which is disprove the launch when they actually safe. So these two events are complementary, so they are a probability sum up to 1. So we just plug in the number and we can get the value 2b minus p squared. It can be easily show that a squared is actually smaller than a, and 2b minus b squared is actually larger than b. So that means serial structure is less likely to make type 1 error and more likely to make type 2 error. So in this case, type 1 error means aggressive error, and type 2 error means you are being too conservative. So in this case, serial structure helps you to be conservative, so to avoid making aggressive errors. Now we can do the same thing for the parallel structure, but in different ways. So let's first consider the type 1 error. In this case, it means because either one of the units approve the launch, so the shuttle will be launched. So that means we need to calculate the event that either A or B approve the shuttle to be launched when actually not safe. And using the similar method before, so it's easy to calculate that the probability of this event happen is 1 minus the event that neither units approve the launch, and then we can translate this quantity to be 1 minus the probability that one agent will make a type 1 error. So now we can do the similar thing for the type 2 error, and now notice that both agents needs to disapprove the launch when it's actually safe. And we can easily calculate that number to be b squared. And as previously, it's easy to show that 2a minus a squared is larger than a, and 2a minus b squared, and b squared is smaller than b. So parallel structure helps you to reduce the type 2 error, but it increases the type 1 error. So in this case, parallel structure will make you more aggressive in that case. So a natural question to ask is which structure should the organization use to avoid disaster? So this question, the answer to this question hinges on your evaluation about the cost of the type 1 and type 2 error. So let's do the easiest example where the cost of type 1 and type 2 error are the same. So we can write the expected cost as the probability of committing the type 1 error times the cost of type 1 error plus the probability of the type 2 error plus the cost of type 2 error. And we can write out a curve where the cost of type 1 error and type 2 error will be exactly the same. And in the case of same identical cost of type 1 and type 2 error, it's easy to prove that this line will be just the line where probability A equal to probability B. So if it is less likely to be to commit a type 1 error, or more likely to commit a type 1 error, so any point here means that A is larger than B, so this is more likely to commit a type 1 error. In that case, it is optimal to adopt a serial structure. On the other hand, for any point that is up the 45-degree curve, that means B is larger than A, it's more likely you will commit a type 2 error than a type 1 error. So you should adopt a parallel structure. So now let's assume in our case the cost of type 1 error is way larger than the cost of type 2 error. Because if you launch a shuttle that you shouldn't launch, as the Challenger shadow demonstrate, it will mean grave cost of the machinery and the human life. But there are also costs associated with not launching a shadow when it should be launched. That means you have to waste all the preparation fee that you spend on maintaining the shadow and get ready to launch. But in this case, still, the cost of type 1 error will be way larger than the cost of type 2 error. And in the simplest way, we can draw the graph like this. So the ISO curve will be severely bent. That means type 1 error, we would like to avoid type 1 error at a high expense of the type 2 error. So that means the whole area here is optimal for a serial structure. So when the cost is way larger for type 1 error, the organization needs to be more conservative. And that is the insight of applying type 1, type 2 error and to analyze the probability of making a mistake for different organization structure.